Hey, welcome back to HVAC-Engineering-Techie channel. This is the channel where we talk all things HVAC. Talk about engineering design, construction, equipment, systems, test and balance extensively, controls, efficiency, and system performance. These videos are intended to be educational in nature to help you advance your career, and of course they'll help you on the job also. Today is another one of the series of balancing systems. Today is TAB, air balancing of outside air systems. Before we start, I'd like to ask you to become a subscribing member. To do that, just hit the subscribe button down below. And if you like the videos, give me a thumbs up. And the reason for that is Google uses that data to evaluate this videos and the channel. So it's really beneficial to me and I appreciate it. It's totally free to you, no expense, no obligation. Just hit the button. It's a piece of cake. It's really easy for you, but it really helps me and I'd be appreciated. Okay, let's start the video. All right, so this is outside air systems. So let's talk about outside air systems. Outside air systems are used to provide conditioned outside air to other air handling units or package units, or to process systems or something other than straight building air itself. Energy recovery units are one kind of unit. Energy recovery air handling units, which are larger units. A DOAS, which is a dedicated outside air supply unit. Makeup air units, MAUs. This is a standard energy recovery unit. They're very simple devices. They have a couple of fans and they have a heat exchanger, and it can be an air-to-air heat exchanger or it might be a simple heat wheel. And they're designed to basically take the exhaust air from the building and exchange its heat with the makeup air to the building. So these heat exchangers, this is an air-to-air heat exchanger, has different bellows in there. And one side is open to the exhaust and one side is open to the inlet air. So these two air streams never see each other, so they can't cross-contaminate or anything. And the system basically has a makeup air fan that draws air in across the isolation damper and across the filter into the unit. And this is an exhaust fan. Basically draws in the exhaust airflow past the isolation damper across the filter and outside. Now the filters are here actually to protect the heat exchanger. If you didn't have this filter, the stuff coming out in the airstream would actually stick here on the supply side of this and would clog this filter. So it's very important that this filter be there and that it be kept maintained. So it has a simple control system. Control system is two motor starters. Normally these are constant volume devices, so the fan runs at a constant speed all the time. They can be variable volume. It's a more complicated system, but normally they're constant volume. So as it draws the exhaust air, and this exhaust air can be coming in from just grills, or it can be other exhaust fans blowing into this system. And this system is just taking up the static pressure here, and the exhaust systems go through, and then the supply air is drawn in through this fan and normally pushed to other air handling units as their outside air intake. Standard makeup air unit, and of course the whole purpose of the unit is for energy economy. So its design is to take the heat of the exhaust and move it to the return air during winter, and taking the heat of the outside air and moving it to the exhaust in the summer. That's what their energy recovery, that's what they're designed to do. All right, so what's a typical sequence? Exhaust and outside air fans shall be on, and the outside air and exhaust air dampers open when the unit is in the occupied mode. Monitor the outside air inlet and outlet temperature, exhaust inlet temperature, and fan status for both fans. So these temperature sensors, if you take this sensor and, take this sensor and that sensor, you can see the total amount of work that your unit has done. This sensor is good to know just what our new temperature is from the return temperature, but basically these are the two that tell how much energy you have recovered. So how do we balance? These are pretty easy to balance. Adjust the outside air dampers at each air handler or AC unit to set the outside airflow, and adjust exhaust grills or dampers to set the exhaust airflow. So when you turn this on, you should have a design flow here that's equal to the outside air units that this is feeding. And remember, these can never have diversity because this has to have enough outside air for an occupied building. So you cannot have diversity. So this should be set up to provide the correct amount of outside air to each air handling unit it's feeding and the correct building pressure. So you have to balance these outside air units outside air intakes on these other units to actually finalize the balance of the system. Measure the airflow by duct pitos. Record the exhaust and outside air airflows and the unit air pressure drop between the inlet and outlet of both systems. That's it. Pretty easy. So now let's look at an energy recovery unit. An energy recovery unit is similar to the this is an air handling unit, is similar to the simple energy recovery unit, except they're large. And these are normally used for large systems as DOAS units of systems that require a lot of exhaust air. These can also be used for large zones like civic centers, basketball courts, sports arenas, things like that require a whole bunch of outside air. So because these units have 100% makeup air and 100% exhaust air. So there's 100% across them. So the systems in the recovery, they have supply fans that blow air out to the space. They have a heating coil, a cooling coil, and we have heat wheels. Now these are all customized units, of course. And you can have more than one heat wheel. This can be a enthalpy wheel, and you may have a dry bulb wheel, which only does sensible heat here. And of course, you have exhaust fans that pull the return air from the building and exhaust it, and then you have the supply fans that pull in outside air across the filters across the heat wheel to the outside. And of course, we have a cooling coil and a heating coil. You can also have a preheat coil if it's needed, and have a very extensive outside air control system. So basically, the outside air system has VFDs on the fans, so these are variable volume. It has a VFD on the heat wheel because the heat wheel speeds are different for different conditions, depending on how much heat it moves. And the manufacturer will tell you what the speeds need to be for whatever. We have isolation dampers to isolate the unit from the ambient. And we have supply air temperature sensor. We have a mixed air temperature and humidity sensor. We have a inlet temperature and humidity sensor. We have a exhaust inlet, return air inlet temperature and humidity sensor. So this is basically about, and these can be quite large. I've done several of them that are 20 or 30,000 CFM. And this is just a simple sequence for this unit. I did one set of units for a big civic center that had 11 loops in an air handler. I've never seen an air handler like. If you look at this basically has 1, 2, 3, 4 loops. That's it. Maybe 5 loops in the wheel. So that one had 11 loops. You can't imagine how complex that engineer made that job. So it is possible to be complicated on this. So let's go through the controls. The supply air return fan should run anytime the system is in the occupied mode. During the cooling season, if the outside air temperature is greater than the return air temperature, then the heat wheel shall turn at the cooling speed to transfer heat from the return air to the outside air to lower its temperature. If the outside air temperature is lower than the return air temperature, the wheel will not turn. We don't want to do heat in the other direction. During the heating season, if the outside air temperature is lower than the return air temperature, then the heat wheel shall turn at the heating speed to transfer heat from the return air to the outside air to raise its temperature. If the outside air temperature is higher than the return air temperature, the wheel shall not rotate. Modulate the chill water and hot water valve to maintain the supply air temperature or room temperature set point, depending on what it's being used for. If the room humidity rises above 60%, start the dehumidification mode. This is a standard dehumidification cycle. In this mode, control the chill water valve to maintain the room humidity set point at 50% room humidity. Modulate the hot water valve to maintain the supply air duct temperature set point. If the room humidity drops below 48%, disable the dehumidification mode. So basically, standard dehumidification, this gets really cold to drop moisture out of the air, and then we reheat it with this coil so we don't freeze people in the space. So standard dehumidification mode, once it gets below 48%, we turn it off, go back to normal heating and cooling mode. Modulate the outside air relief and return air dampers to maintain building pressure and ventilation air. So it's not actually an economizer, but we got 100% return air exhaust, we got 100% makeup air, and we just vary the difference between the two to set the building pressure. Monitor the room air temperature and humidity, supply air temperature, and supply and return air status. All right, let's talk about balancing this unit. Test the fans, chill water, and hot water coil to verify operability. Make sure it can produce temperature and air. Manually set the fan speed and exhaust fan speed to deliver design airflow with all connected dampers locked at full airflow. So you're going to set this up so you got full design flow. And then if the unit feeds other air handlers as a DOAS unit, adjust outside air dampers that each air handler serve for proper operation and flow to design. Verify building pressure at each air handling unit. So now you're going to make sure their outside air is correct. But remember, they need to be locked in their open position, the design flow, for them to do proper operation of the air handler. If the unit feeds room VAV boxes, balance and calibrate all boxes. See T-17 for the balance of VAV systems. All boxes and grills should be proportionally balanced if the system has diversity. See T-20 or tab for diversity. Measure the unit final airflow by duct pitot and input the final differential pressure set point. So now that you have everything downstream balanced correctly and you have this one set up and it's maintaining building pressure correctly, you go check the supply air duct static pressure set point, and that'll be its design set point that you input into the system. Adjust exhaust fan flow to provide at least 0.015 building pressure. Could be 0.02, but we'd like it to be above neutral if possible. Adjust balance valves to set the coil water flows. Record entering and leaving air pressure for the supply air and differential air pressure across the filters, and each chill water and hot water coil. Record coil water flows. Release all outside air dampers to automatic operation. So now you've balanced that and it's in automatic operation. As they're big, impressive units, but as far as balance is concerned, they're not terribly difficult. So here's a dedicated outside air system, air handling unit. And these, of course, are used to provide air to other air handling systems or other package units, you're not sure. And of course, they normally are configurable by how many coils. So if this is in a cold zone, you could have a preheat coil, but normally you'll have a chill water coil and a hot water coil set up in a dehumidification configuration. And of course, then these go down to other air handling units or other package units. And the reason for this is we want to put all the complexity up here in one unit instead of having all that complexity down at each unit. Plus, we want to be able to maintain the outside air filtration all in one location. So these are used to make it simpler and to provide a better environment. Now, they're designed to trim off the outside air. They're not designed to provide cooling to the unit. They're designed to actually feed this at return air temperature. So we're just trying to trim off the air. We're going to change its temperature. We're going to change its humidity level if needed in these spaces. So it's going to take care of all that conditioning of the outside air. And it got an air handling control system, basically, that's providing coil control, fan speed control, differential pressure sensor. We have a room pressure sensor and room humidity sensor. We have a supply temperature and humidity. We have return temperature and humidity. And we have a preheat coil temperature set point. And of course, we have valves, control valves. Controls of these units. Okay, typical control sequence. Make sure everything runs so it can do air and temperature. Modulate the supply fan speed to maintain the supply duct pressure set point. Reset the supply duct pressure set point to maintain the room pressure set point. We have all these units, and what we really want to do is maintain this pressure set point so all of these have the right amount of air. So what we normally do is look at the room set points and pressure. And if all the room set pressure set points, and normally there's not one for air handler, there's one for space, are okay, then you're not going to reset it. If they're too low, then you need to reset it up a little bit. If they're too high, you want to reset it down, because this unit is controlling the building pressure. Modulate the chill water valve and hot water valve to maintain supply air temperature set point of 80 degrees. Reset the supply air temperature set point to equal average return air temperature of all connected units. So again, like I said, we're not trying to provide air conditioning. We're trying to relieve these air handling units of their outside air load. So what we want to do is we want to maintain this temperature, supply air temperature, equal to the return air temperature of all these units. And the reason we do that is we don't want to reheat any unit. So if this unit needed heat and we're providing too cold of outside air to it, it's going to reheat the air. So we don't want to do that. So we'll keep this at average. Now, average is not best. We could low select or high select, but in this condition, average is best. Average means that no one's happy, basically, because it might be some a little colder, hotter than it, but the best way to do it is average. Modulate the pre-hot water valve to maintain the minimum outlet temperature of the pre-coil at 45 degrees. So we're going to make sure it trims off the excess heat so it doesn't let it get really cold. If the room humidity, and this is a standard dehumidification cycle, so if the room gets above 60%, we're going to go into dehumidification mode. In that mode, we're going to open the chill water valve, and we're going to drop the air coming out of the chill water valve to get a lot of moisture out of it. And we're going to modulate that chill water valve. So first, when it starts, it goes full open. And then it watches the room humidity and will modulate that valve to 50%. Now, the reason it does that is to save energy. If we dropped it full open and didn't modulate it, it would overcool the air, and then we'd read it back up. Now, we will get the humidity sooner, but basically it wastes more reheat. So basically what I normally do is modulate it to 50% humidity. And then as the room drops below that, because whatever's causing humidity is less, then at 48% it'll go out of dehumidification mode. And of course then it runs the heating coil as reheat to keep the temperature of the outside air correctly where it should be. Monitor supply air temperature, room humidity, and supply air fan status. Okay, how do you balance one of these? Test the fan, chill water valve, hot water valve to make sure it's got air and it's got temperature control. Manually set the fan speed to deliver design airflow with all connected dampers locked at full outside airflow. So you've gone out to these air handlers, and these have all been set up for maximum outside airflow, because these are probably all VAV units. So we want to make sure this is at the maximum ventilation air supply or building pressure supply that it requires. So these are all set at their maximum design flow. And then we're going to, once we do that, we're going to adjust the outside air dampers to each air handling unit. So we're going to set this unit is set at design flow and locked in pressure. And these are at maximum speed. Now remember, there should never be diversity. So this fan should have plenty of air to feed these units at design flow. And you lock that damper position, and then you verify that these are all correct. Adjust the outside air at each air handler served for proper operation and flow to design. And verify building pressure. So we want to make sure these are balanced to design, and we have set this unit so that the building pressure is correctly with these all at maximum at their design position. So once we have that, then we're going to verify building pressure is okay and measure the unit airflow by duct pressure. We want to measure the flow in this duct, and we want to read the supply air duct pressure set point, because we've not dealt with this yet. And with these at design flow, and locked at design flow, and this at design flow, that static pressure will be the pressure we input into the controller to maintain that supply duct. Adjusted balance valves to set the coil water flow. Record entering and leaving air pressure for the supply air fan, differential air pressure across filters, and each chill water and hot water coil and the filters. And then, of course, record the flows. Release all outside air dampers, automatic operation, so these are all automatic, and then release the supply air fan, so it's an automatic. And then you're done, you're balanced. They're not too difficult to do, except for you have to balance this one after you've balanced all of these. So you have to go to each air handler to set them up, but once you've done that, it's a pretty simple system. So this is a makeup air unit. Now, a makeup air unit is similar to a DOAS unit, except it's not trimming off outside air. It's actually providing makeup air for some kind of process. Might be a kitchen hood, might be a laboratory making up for biohoods. It could be for an industrial process making up for fume hoods or capture hoods, or it could be some other space that's making up air for something that's affecting building pressure. So basically, these are the makeup to prevent screwing up building pressure. So of course, they have a control system. It's pretty simple. Almost always constant volume. There can be VAV, but normally it's not required unless you have an active building pressure sensor. So normally it has a constant volume fan, it has a cooling coil and a heating coil, and normally in this configuration, not set up for dehumidification. And the reason is because they're just dehumidifying, they're tempering air that's going to be wasted, right? It's going to be exhausted. So basically we just want temperature. We don't want anything fancy. We have filters, and we have an isolation damper on the outside air. Okay, control of these units, of course. Supply fan runs, and the outside air damper shall be open anytime the system is in the occupied mode. So when they occupy it, comes on, that opens, and it's tempering air.
Modulate the chill water valve and hot water valve to maintain supply air duct temperature. Set point should be operator adjustable, and the set point should be 75 degrees. So like if these are used in the kitchen, they have a switch on the hood to turn it on. And they may even have a temperature adjustment, might be on their computer, but these are actually airs blowing on people, so that's why it has to be set at a lower temperature. And that set point may be 72, may not be 75, but it'll be something that's capable of people. Monitor the room temperature, supply air temperature, and supply air fan status. Pretty simple control. So how do you balance one of these? Pretty simple. Again, test the fan and coils so they can provide air and provide temperature to the space. Adjust outlet dampers and set the supply airflow to the design values. So you set this up so it's doing design flow or close, and then you go down and balance whatever it is. I mean, it may have almost nothing. It may just blow into a big space. So you may just have to pee to the supply duct, or it may be to a bunch of grills in a hood, a push hood, and you may need to balance those grills. Once you've done that, you come back and make sure this unit is set at this flow, and you have it. It's a constant volumes, so it's locked in the pressure sensor. Now, adjust the dampers and supply air flow design values, measure the airflow by duct pitot, and adjust the balance valves to set the coil water flow, right? And then record the flow and variability pressure at set point when unit is operating. Record the leaving, entering fan pressure, chill water, and coil flows. And one thing I forgot to mention here is that, remember, this is actually affecting building pressure. So you do need to measure building pressure. And if building pressure is too high, then you need to lower the flow. So it doesn't matter, I mean, because that's what we're doing is affecting building pressure. So we'll lower the flow below design to make sure building pressure is correct. If building pressure is too low, then we'll raise the flow of this to get building pressure up slightly. It's pretty simple. Since we are not affecting the exhaust side of this equation, that's whatever the process is, we are only on the makeup side. So that's what we have to do is adjust this. Once you've balanced the grills, we want to adjust this flow for building pressure. And that's the end of outside air systems. Pretty simple. I hope that was beneficial for you. Appreciate you being here. Appreciate you being a subscribed member. Have a great day, and I'll catch you on the next one.